Okay, so today we're going to be diving into something pretty fascinating, the world of social media and all that data, right?
Yeah.
I mean, think about it for a second. Every single day, platforms like Twitter and Facebook, they just get absolutely slammed with new information. Posts, updates, opinions. It's kind of mind-blowing when you actually stop and consider the sheer volume of it all.
Yeah, it's a data deluge for sure, and it leads to a pretty significant challenge for anyone who wants to stay informed in this day and age. I mean, how do you sift through all of that noise and find the truly important stuff happening right now?
Exactly. And that brings us to the idea of automated event detection. Because let's face it, manually analyzing that much data is just impossible.
And that's where things get really interesting. These automated systems are becoming essential for all sorts of reasons. Think about it, for our listeners, it could mean getting those crucial news updates without getting lost in an endless scroll.
Right. But there's a catch. Our sources point out that a lot of the current methods, they tend to focus heavily on the raw numbers, the statistics, like how many times a word appears or how quickly it's trending.
Yeah, and while that can give you a general sense of what's popular, it often misses a really crucial piece of the puzzle, the actual meaning behind those words.
The linguistics, right? Specifically the semantics.
Exactly. Ignoring that semantic layer means you're losing a huge amount of valuable information. You might know a word is popular, but you don't really understand why or in what context.
So that's where WhatsUp comes in. It's a new approach that tries to address this limitation. And that's what we're going to be exploring today, how WhatsUp detects not only when something important's happening on social media, but also the really specific textual details of that event.
It does that by combining those statistical patterns with the linguistic meaning, bringing both sides of the story together.
Now, one thing that really stood out to me is that WhatsUp isn't limited to a specific language or platform or even a particular topic.
Right, because it uses something called self-learned word embeddings and unsupervised learning. It can handle social media data from pretty much anywhere.
So it can even adapt to things like slang and abbreviations and all those, inevitable misspellings we see online.
That's what the researchers call data-specific linguistics. It's a pretty cool concept.
Absolutely. So our main source today is a research paper that introduces and evaluates WhatsUp. And to really test it out, they applied it to real-world data from two very different areas, both from 2019.
They looked at the online chatter surrounding a Manchester United versus Liverpool football match. A very intense rivalry, lots of real-time reactions happening there. And then they also analyzed data from the Brexit Super Saturday Parliament session.
A pretty stark contrast in terms of how quickly events unfold and the kind of discussions people were having.
Yeah, it provides a good test for WhatsUp's ability to adapt to different scenarios.
Okay, so we've got a problem. We've got a potential solution. Now let's actually break down how this WhatsUp system works.
All right, so the overall process is broken down into three main stages. The first one is data processing. Remember that flood of social media posts we talked about? WhatsUp takes that continuous stream and divides it into smaller, more manageable chunks of time. These are called time windows.
Okay, so it's kind of like taking a video and breaking it down into individual frames.
Exactly. And the length of those time windows can be customized depending on the data you're looking at. For something as fast-paced as a football match, where, a goal can happen in seconds, you'd probably want very short time windows.
But for something like a political debate, where things develop more gradually, you might need longer windows.
Right. And within each of those time windows, WhatsUp creates those word embeddings we mentioned earlier, turning words into numerical representations that capture their meaning.
And it also keeps track of the word frequencies, how often each word appears within that window.
Exactly. So step one is all about organizing the data and getting a basic understanding of the language and word counts within each time slice.
Got it. So then what's next?
The second step is event window identification. This is where WhatsUp tries to pinpoint when something significant happened. It does that by comparing the text in one time window to the text in the window right before it.
So it's looking for those moments where there's a noticeable shift in the language being used.
Right. Like if there's a sudden change in the topics being discussed or a bunch of new keywords appearing, that could signal that an important event has occurred.
And if that change exceeds a certain threshold, then that time window gets flagged as an event window.
Precisely. It's like setting off an alarm.
Okay. And what about that third and final step?
So the third step is event cluster detection. Now that WhatsUp has identified a specific time window where an event likely happened, it zooms in on that window to find groups of words or clusters that seem to represent specific sub-events within that window.
Okay, so it's like identifying the different conversations or threads that were happening within that event window.
Yeah, exactly. Like if during that football match there was a sudden spike in posts mentioning goal and Rashford, those words would likely get grouped together because they represent that particular scoring event.
Interesting. So those are the three main stages. Now, let's dig a little deeper into some of the specific innovations within WhatsUp, especially when it comes to identifying those event windows.
Okay, the first one we'll look at is local dendrogram level, LDL similarity. Now, to understand this, we need to talk about dendrograms for a second.
All right, so a dendrogram is basically like a family tree, but instead of people, it shows how words are related to each other based on their meaning, those word embeddings.
Right. And words that have similar meanings, they'll be closer together in this tree-like structure.
Got it. Now, there was an earlier measure called dendrogram level, DL similarity, which tried to quantify how similar two words were based on how many levels of that meaning tree they shared. But the researchers behind WhatsUp, they found a problem with this DL similarity. It could get thrown off by noise in the data. Yeah, you know those general everyday conversations that happen even within a filtered stream of social media posts. Like, even if you're looking at tweets about a football match, people might still be talking about, I don't know, the weather or what they had for lunch. And that can mess with the DL similarity calculations.
So even if two words are closely related to an event, the presence of all those other unrelated words can make them appear less similar than they actually are.
Yeah, because the DL similarity looks at the entire depth of that meaning tree. So if you introduce a bunch of unrelated words, the relative shared level between those event-specific words becomes smaller.
It's like that saying, can't see the forest for the trees.
Exactly. And that's where LDL similarity comes in. It's an improvement because it takes a more focused approach.
How so?
Instead of looking at the entire tree structure, it just looks at the specific path between the two words you're comparing. So even if there are a ton of unrelated words in the data, the LDL similarity between those two event-specific words should stay high because their relationship within that local part of the tree is still strong.
So it's like zooming in on the relevant section of the map instead of looking at the entire globe.
Right. It helps filter out the noise. And then these LDL similarity scores, they're used to build a similarity matrix for each time window.
Okay, so that matrix basically captures how all the words within a given time window are related to each other based on their meaning.
Exactly. Now, another interesting aspect is the idea of non-relative versus relative dendrograms. This has to do with how those word relationships are constructed across different time windows.
Okay, I'm listening.
Some older methods, they would use a common vocabulary across two time windows, meaning they'd take all the words from both windows and build one big relative dendrogram.
That makes sense. You need a consistent set of words to compare, right? But
Well,
what's the problem with that?
the problem is that some of those words might have been very rare in the previous time window. And if a word only appears a few times, the model might not have enough data to learn a good representation for it.
So those rarely used words could actually end up skewing the results.
Exactly. And that's why WhatsUp uses non-relative dendrograms. So for each time window, it builds the dendrogram only using the words that appear in that specific window.
So it's creating a fresh understanding of the relationships for each slice of time.
Right. Avoiding any potential bias from those rarely used words.
Smart. Now, what about positive similarity change? How does WhatsUp analyze changes in those similarity matrices between different time windows?
So for this, they create a difference matrix, basically subtracting the similarity matrix from the previous window from the current one. Now, some methods might just look at the absolute similarity change, treating increases and decreases in similarity as equally important.
But that might not tell you the whole story, right? Because an increase in similarity could mean that new words are becoming strongly linked to existing ones, which often indicates a new event. Whereas a decrease in similarity might just mean a topic is fading away.
Right. And that's why WhatsUp focuses specifically on positive similarity change. It only looks at the increases in similarity because those are often more telling when it comes to identifying significant events.
Okay, so it's emphasizing those situations where words are suddenly becoming more closely related. And the last key innovation we need to talk about for event window identification is frequency difference-based vocabulary change, FDVC.
This one focuses on changes in the actual words being used.
Right, exactly. While changes in word relationships are important, so are changes in the vocabulary itself. A simple approach might just look at any new words that appear in a time window, but FDVC goes a bit deeper than that.
How so?
It doesn't just consider any new word, it only focuses on new words that also have a significant increase in frequency compared to the previous window. So it's not just a random word popping up once or twice, it has to be something that's suddenly being used a lot.
So it's really trying to pinpoint those emerging terms that are likely tied to an important event.
Exactly. And to get an overall change score for each time window, they found that simply averaging the positive similarity change and the FDVC gave them the most robust results.
Okay, that makes sense. So that covers how WhatsUp identifies the event windows.
Yeah.
But how does it figure out those specific co-occurring events within those windows?
Right. So once it's identified an event window, the next step is to figure out those word clusters. And the first thing it does is token ranking. It ranks all the words and even emojis based on how much their textual similarity has changed compared to the previous window.
The logic being that words that have a sudden shift in their relationships with other words are probably connected to that new event.
Precisely. They tried different ways to calculate this weight for each word, but ultimately what worked best was combining the average change in similarity, using that LDL similarity measure, and the change in frequency.
So words with a big shift in relationships and a noticeable change in how often they're used, those get ranked higher.
Right. And once you have that ranking, the next step is cluster generation. This is where WhatsUp groups together words that are linguistically closer to those top-ranked keywords.
And again, they use LDL similarity to determine that closeness, right?
Exactly. They tested two different approaches here, one using a similarity-based threshold and one using a count-based threshold to decide how many words go into each cluster.
And did one approach work better than the other?
Well, it seemed to depend on the type of events they were analyzing. For those structured events, like in sports, where a specific action usually involves a fixed number of key players, the count-based approach worked really well. But for less structured events like political discussions where things are more varied, the similarity-based approach was more adaptable.
That makes sense. Then they also have this novelty measure. What's that for?
So each event cluster gets a novelty score, which is basically the average weight of all the words in that cluster. It helps to gauge how new or newsworthy that particular event is.
So a higher novelty score means the event is more of a departure from the ongoing discussion.
Exactly. And finally, there's cluster pruning. Because even within a specific event window, you might have lots of ongoing discussions, not all of which are actually newsworthy.
So how does WhatsUp decide which clusters to keep?
Well, instead of trying to set a fixed threshold for importance, which can be hard to do, it simply limits the number of top-ranked keywords that are used to create clusters in the first place.
So it's focusing on the most significant changes and ignoring the rest.
Right. It's a more adaptable way to handle that constantly changing social media landscape.
This all sounds very promising. But how does WhatsUp actually perform when you test it out on real data?
Well, the researchers tested it on those two data sets we talked about earlier, the MUNLIV football data and the Brexit vote data. They compared it to other state-of-the-art methods like Maybed, SekiTwick, and LDA-Set.
How did it do?
It consistently outperformed all the other methods in identifying both the timing of the events and the content of those events, and by a significant margin.
Wow. So it was actually able to find those event windows and clusters more accurately.
Yeah. For example, they used a metric called Time Window F1 to evaluate the accuracy of the event window identification. And WhatsUp scored about 15% higher for the MUNLIV data and 9% higher for the Brexit vote data compared to the best of the other methods.
That's pretty impressive.
Yeah, and they also looked at how the different clustering approaches, the similarity-based and the count-based, performed in each context. And as we said before, the count-based approach was really good for the structured sports data, while the similarity-based approach was more adaptable to the less structured political data.
Okay, that makes sense. Now, for our listeners who might be thinking, this sounds cool, could I actually use this myself?
Yeah.
The researchers do talk about the possibility of customization.
Right. WhatsUp isn't meant to be a one-size-fits-all solution. It has several parameters that you can tweak.
Like what?
Well, for starters, you can adjust the time window length depending on how quickly you think events are going to unfold in your area of interest. Shorter for fast-moving news, longer for slower developments.
Makes sense.
What else? You can also adjust the change threshold, alpha. This determines how sensitive the system is to changes in the data. A higher value means it'll only flag time windows with really significant textual shifts as potential event windows.
So you can filter out some of the less important stuff.
Exactly. And then there's the frequency threshold, theta, which helps you get rid of those noisy, low-frequency terms during that initial data processing. You might need to play around with this depending on how much background chatter there is in your data.
Okay, and what about those clustering parameters?
Right. So you can choose between the similarity threshold, S, and the keyword count, M, to decide how words get grouped into clusters. The similarity-based one's probably better for diverse events, and the count-based one might work better for more structured events. And you can also adjust the keyword count for pruning J, which controls how many potential event clusters the system even considers.
So there's a lot of flexibility to tailor what's up to your specific needs and the type of data you're analyzing.
Yeah, and the researchers give some initial suggestions for these parameters, but you'll likely need to experiment a bit to find what works best for you.
All right, so we've really gone in depth on what's up today. But what's the key takeaway for our listeners?
I think the main point is that WhatsUp offers a more sophisticated way to automatically detect events on social media. It doesn't just rely on simple word counts. It also considers how those words are related to each other and how those relationships are changing over time.
So it combines that statistical analysis with the understanding of linguistics.
Exactly, and that allows it to detect both when events happen and the specific details of what's being discussed.
Which then makes you wonder, now that we can potentially do this, what are the possibilities? What could we use this information for?
That's a great question. The researchers themselves suggest some interesting avenues for future research. For example, could we automatically generate summaries of those events as they happen? Could we track how those events evolve over time and how people's opinions about them change?
It definitely opens up a lot of interesting possibilities. So for you, the listener, think about how something like What's Up could be useful in your own life.
Whether you're trying to stay on top of trends in your field, understand public reaction to a certain topic, or maybe even get early warnings about developing situations, this kind of technology could be really valuable.
And if you're interested in diving even deeper into the technical side of things, you can check out the research paper we discussed, and they've also made the code for What's Up publicly available.
That's a great resource for anyone who wants to get their hands dirty and explore further.
As we all try to navigate this ever-growing world of social media, it's clear that we need better tools to make sense of it all. And What's Up is a great example of how we can use a combination of statistics and linguistics to get a deeper understanding of what's really going on. It makes you think about all the other insights we could potentially uncover as these kinds of technologies continue to evolve and get even more refined.
Yeah, the future of information processing is definitely exciting.
It is. And with that, we'll wrap up our deep dive for today. Thanks for listening.